All right, sixth grade, our objective today is to talk about the projects from Friday, and then if there's time, we're going to talk about writing linear equations, which is a completely different lesson, new lesson, but I think because you guys did the graph projects Friday for homework, that should make this lesson a little bit easier for you. So I'd like to start it today and probably finish it tomorrow. If not, we will do this tomorrow. Chapter 10 test, the earliest it could be is Friday, but I have a feeling it won't be until the beginning of next week. Okay, so just an FYI to you guys, we are getting to the end of the chapter, but I don't want to rush these last couple sections because they are important. All right, let's go over the warm-up. Briar, the page is 138 in your homework packet. If you want to pause the video and try these numbers before we go over them, go for it. Okay, number 1 on the warm-up. Matt, we'll start with you. Okay, what's M though? You define the slope and the y-intercept. No. What's the slope? If it's y equals a number. Good. Slope is 0. Okay, and then write the y-intercept as an ordered pair. So tell me what it is as an ordered. Okay, thank you. Matt, you're always slacking on Monday mornings, huh? Just kidding. And the H, number 2. That's not correct. It's x equals -4. So if it's x equals -4, what's the slope? X equals a number. X goes this way. Good, undefined. Emma H, what's the y-intercept? X equals a number. It goes this way. Does it ever go through the y-axis? If it never goes through the y, it's nothing. If it never goes through the y-axis, it's none. There's not a y-intercept. Okay? Shh. Does it go through the y-axis at 0? Number 2 is x equals -4. Annalise, here's the graph. So the line would be going through -4. Okay, it's a vertical line. It's never going to touch the y-axis, ever. Okay, number 3, Doug. Okay. Good. Good job. 0, -13. Make sure you guys checked 1 to 3. Charles, number 7. No. Number 7 has different directions. Good. Good job. Okay, Annalise, number 8. Good. Good job. Jeremy, number 9. Okay. Mary, number 9. Good. Good job. Number 10, or number 13, sorry, Donatus. Donatus, is it done? Okay. Good, they're parallel. Alyssa, 14. Didn't get there. Okay. Justin, 14. Good, neither. Zach, did you get to 15? Okay. Emma M, did you get to 15? What'd you get? No? Adam, 15? You had neither. Sean, 15? Oh, no. Charles? Yeah. Hey, guys, remember, y equals a number is horizontal, x equals number is vertical. They're always perpendicular. A horizontal line and a vertical line are always perpendicular. Okay, Emma H, 16. Good job. Okay, before we talk about Friday's projects, questions on the warm-up? Annalise? Well, 14 is neither. Okay, 13, did you put them both into y equals form? That's why. You always have to have them in y equals mx plus b form to graph them and or determine if they're parallel, perpendicular, or neither. You can't just look at them the way they are. They have to be in y equals mx plus b form. Okay, did you get it into y equals form, number 3? Okay, that's probably the problem. Okay, so number 3, you had negative x minus y minus 13 equals 0. So Annalise, what did you move first to get it in y equals form? Okay, so you added 13 to both sides. Okay, so we have negative x minus y equals 13. Then what'd you move? Good, so plus x. So we have negative y equals x plus 13. That's why. You just got to be very careful. Then divide everything by negative 1. So you get y equals negative x minus 13. Okay, anyone else on the warm-up? Okay, so before we talk about weekends, let me just address any questions you guys have from Friday's assignment. So hand up if you have a question on something. If you want to show me something, I'll come around and see it. But what questions do you have, Sean?
We have to label the lines, right?
Yes.
Points.
Correct. Correct, yes. So you guys should have labeled the lines. Like this line could be A. We're going to fix some things, MH. I'm going to give you time to fix things. The lines, yeah. The lines on the graph. Nope. The lines on your graph, yes, should be labeled. Emma M, go ahead. Okay, but you should also have on the graph, like label each line, so when I grade it, I can make sure that you did everything right. But I'm going to give you time to fix that, okay? Mary. Yes. Yep, that's perfect. Matt. Hold on. You don't need to label points because all you need to do, if you just show me the equation, I know what points are on it. So just like remember on Friday we did in class where I would draw a line, you guys gave me the equation. Okay, let me come look at yours, but you don't need to label any points. I just need you to label A, B, C, D, blah, blah, blah for each equation, which is each line. You don't have to label points. If you did, it's not wrong, but it's just easier just to label the line. Okay, Emma H. Okay. That's fine. Yeah, if you did eyes or just like points for something, that's different. That you should. Charles? Yeah, I'm gonna come around and look at them before I decide if we're doing that or not. Okay, any other general questions before I tell you what we're gonna do now? Hold on. Okay, so Briar, I'm gonna pause the recording for a little bit. If you need to finish up your graph from Friday, that's what you're gonna do. Those of you that are in here, I am gonna Okay guys, we are in our notes on page 23. Just a reminder for your projects to be to the side for now. You guys, if you still have them, give them to me tomorrow. Briar, we spent some time in class kind of talking about them, so make sure you bring yours to class tomorrow. Donatus. Fun stuff? What fun stuff? The coloring of your projects, you mean? In about 3 days. How did you know that was coming? Okay, you just looked ahead. Okay. Very good job, Donatus. We're getting there. All right. Did you? I'm going to have you teach one day. Both of you. I'm kidding. I'm kidding. All right. Okay, I'm just kidding. Okay, shh, shh, shh. Quit yelling at me, everyone. Okay, page 23 in the notes. So let me just kind of summarize again what we're doing here. This lesson will help you guys if you are having trouble with writing equations for the project that you turned in. I will need about 5 days, so hopefully by the end of the week I'll have majority of them done. I want to check all your equations. If something is wrong, I will make a note on there, probably in pencil, so if you want to fix it, you can. But in regards to grading them, I do have them worth 20 points, so when I do give them back, I'll explain how I did that, okay? All right, so page 23. It says this is a warm-up, but I want to do this with you guys. It says, explain the slope-intercept form of an equation to someone that has no prior knowledge. If you had to explain to your peers this equation, or to someone in your family that has no clue what this means, what's one thing you could say? Emma H. Okay, good. Perfect. What if they still say to you, I still don't know what that means. Can someone add? What else could you say? Doug? Yep. Yep. That's what Emma said, though. Okay, perfect. Perfect. I like that. Annalise?
Well, you could say, like, if they don't know what slope is, you could say that it's the number of blocks on the right that you rise up over the number that you go to the right.
Awesome. You could explain about it being the rise over the run. Good. Jeremy? That's a lazy way out. Okay, but that's not going to help. Sometimes people have to hear it. So what else could you say, Mary? Slope what? Oh, how steep. Okay, good. So steepness of a line. Perfect. Donatus, what else could you say? Okay. So how about where a line crosses the y-axis? What if I say that? How far up or far down? Yeah, but I like where you said where it crosses the y-axis, because they should know that. I'm hoping that this is the y-axis. If not, Donatus, we could draw it for them and show them. Sean, what else could we say? Good job. Very good. How did you just thought of that? That's today's lesson. Hmm? I know, we kind of did. Very good job. Charles, we kind of. Say that again? Oh, goodness. All right, anything else? You guys are missing. What's one other word of slope that we talked about that could help? Emma? Good, rate of change. So you could give them an example, of how many miles you walk in a day, or how many homework problems you complete in an hour. If you relate it to real life, it might be a little bit easier for someone to understand that doesn't know math. What's another word for the y-intercept? So if this is like rate of change, steepness of a line, anyone remember, what's another word to apply it to real life? Annalise? You're close. The something point, but not the stopping point. The starting point. Perfect. For example, if you guys belong to a gym, okay, you might pay a one-time fee of $30 a year. Okay, you pay that once. That's your starting point. From there on, you pay a monthly fee of, let's just make it up, $12 a month. Okay, the y-intercept is always your starting point when you're applying it to a real-life problem. It could be like a grade in this class. Maybe I start off your grades with, you all have a 75%. You either go up or down from there. Okay, I wouldn't do that, but your starting point, there's a lot of applications to that. Donatus? Can you call slope what? Sure, if you want to. Okay, let's look at example 1. Okay, example 1, write an equation of a line with a slope of m and a y-intercept of -7. Matt, what variable is slope? All right, you don't like Mondays. Alyssa, what variable is y-intercept? Good. So y equals mx plus b. Adam, plug them in. Good. Okay, second one. Write an equation of a line with a slope of -1 and a y-intercept of 8. Mary, what variable is slope? Good. Jeremy, what variable is y-intercept? So what's the equation? Sean? Awesome. Isn't this pretty easy? Okay, Questions on given M, given B, throwing them into an equation. Mary, you serious? Oh, okay. Just making sure. I don't. I shouldn't assume things. Sean, we are really learning this. Ah, come on, guys. All right. Here's the reason it's easy. It's because when I taught you the other lessons, I added things into them and made it harder. The book does not do that. Okay, number 3, ready? Write an equation for each line shown. So look at number 3 on your paper. You're on the wrong page. Okay, what is the M? Just leave it there. What is the M on number 3? Raise your hand when you know. What is the M? Emma H, what's the M? 3 over what? Good. Positive or negative? Good. Positive. Okay, what is the B, Doug?
2.
Good. Positive 2. Mary, what's the equation?
The equation is y equals 3x plus 2.
Awesome. Easy, huh? Okay, Donatus, in letter B, what's the M? What's the M? Good. 0. Justin, what's the B in letter B? Good. Sorry, I'm looking at the wrong thing. Good. 1. So what's our equation, Sean? Good job. So it goes this way. Slope is 0. Equation is y equals a number. Always. Annalise. You can, but 0 times x is just 0. But you can't do that. Any other questions on that? Okay, letter C is where it gets to be a little bit different. Okay, we need to write an equation that goes through the points -2, 6, and 0, -4. How do we do this? Charles? Good job. First thing you have to do, given 2 points, to write an equation, label them. x1, y1, x2, y2. So label them. So on your projects, if you're having trouble with your diagonal lines, if you pick 2 points, you can find the equation from 2 points. Okay, here's how you do it. Using the slope formula, we have to find the slope. y2 minus y1 over x2 minus x1. So plug them in. We have -4 minus 6 over 0 minus -2. -4 minus 6, Alyssa, is what? Good. Emma M is 0 minus -2 is what? 0 minus -2. Good. Positive 2. So that reduces to -5 over 1, or just -5. So that's step 1. Find the slope. Step 2. Plug the slope into the equation. So we have y equals -5x plus b. Now, it says to find b. Anyone want to make a comment on that? Find b. Alyssa? Okay. Donatus? Yes, good. So when x is 0, that's going to be the b. Is that what you're telling me? Okay. Mary? Yep. So let's use this point. Let me just show you what you can do. If you don't know what b is, it is -4. But if you're not given the y-intercept, let's pretend like that wasn't the y-intercept. You would pick a point, plug this in for x, plug this in for y. So look, -4 equals -5 times 0 plus b. -4 equals 0 plus b. So yes, we know b is -4. We got that just by looking at the ordered pair. That's why you guys were all looking at me like I was crazy, because you don't have to plug it in. But if you are not given 0, a number, that means you don't automatically know what b is. You need to take a point, plug it into the equation, and find b. So Charles and Donatus were right. The equation is y equals -5x minus 4. This will help you on your projects if you're having trouble with the diagonal lines. Doug? You can use either point. No matter what point you plug in, you're going to get the same b value. Does that make sense? Okay. Annalise?
For
that's what Doug just asked. It doesn't matter. You can pick either one and plug it in. However, Annalise, if you're given the y-intercept, this is the y-intercept. If you're given the y-intercept, that's your b value. Okay? But you're not always going to be given the b value.
And also, like, so you're always going to put, if you have to plug it in, the x value is going to be multiplied by.
Yep. We're going to do more of this tomorrow. I just started it today. We're not. Emma? Yes. Yes. Okay, Matt. Yeah, and we got to go. So my fault. Tomorrow morning, as soon as we come into class, Matt, remind me, please. I'm sorry, guys. I get off on a tangent and I lost track of time. Okay, so homework. Finish the project. Also, practice 8.6, 1 to 7. That's it. So finish your project. This homework should take you literally 2 or 3 minutes. Okay? I promise you we'll spend about 5 or 10 minutes talking about weekends tomorrow. Sorry about that. So 8.6, 1 to 7. Projects, finalize them today. Give those to me tomorrow so I can grade them this week. Okay? Good job today, guys.